you will get to know as we move on. We have this thing, the reservoir use braking system, and then just escape battery, and then escape off the that is low volt, and then it's not enough, or it is above the requirement of the traction motor. So we need to step it down to a reasonable current or quantity. That is that. So we move forward. So as you can see, we are assembling everything. The boogie was in place. This is how it's being assembled. Yes. So now, after the assembly, we have to place the whole vehicle on top of the boogie. So this is the boogie. This is the whole design of the vehicle or the carriage. You can also call it the host. So this is the pantograph out. This is the overhead asset earlier. So this thing, by some mechanism, it is being converted to or transferred to the transformers, and then they reduce it to the induction motor, the traction motor, also convert it to mechanical rotational motion. We convert it to rotational motion, which sets the train, the whole train into what? Into motion. So as the train is moving, we don't want sliding of this thing off the rails or the chassis holds the vehicles and everything in place. Alright, so let's move on. Alright, so can you move forward a bit for me to see the complete assembly of the train? I guess they are not hearing me. Alright, so let's move on. So this is the pantograph. This is the pantograph that we are talking about. This is the pantograph. Please, I want to see my pantograph. Please, I want to see my pantograph. Alright, so the pantograph receives, as I said earlier, receives the power from the overhead lines or OHL to the transformers, and then we do that thing convert to rotational motion. The transformers is what it has also, it's also equipped with pneumatic cylinder, the springs and all that helps me to minimize. So that is that. Alright, so let's move on. Let's skip the video and let's talk about some material used for the various components that we did. So what we see here is the conceptual design, where we had interest for, as I said earlier, that we had inspiration from our research from such industry like cement and then the railways. We combined all those things and then we built something out of it, as we showed in the video. So material used for the crossbar, we used AISI 4130 that is American Iron Steel Institute. That is the full meaning of AISI. So reason for the selection of this material is what? The strength to weight ratio, high resistance fatigue, because on the crossbar or at the boogie is where all the forces and all the stresses by the train rest. Alright, so we move forward to the boogie frame. Please, hello. Please let me use this one too. Alright, so this is as show that we know what we are doing. And this is a primary suspension, full video of a clear view of the primary suspension. So the material selection also is what? That AISI 4340, and then the steel, we move forward. We have also the secondary suspension that we talked about. So isolate the car body from boogie vibration, provide smoother ride comfort for the passengers, and then the material selected is rubber reinforced composite steel at the top of this. Then the pneumatic brake system. Alright, the pneumatic brake system, it uses air compressor. So as the air is compressed, it forces the brake discs to hold the brake discs on the axle, and then to cause the deceleration of the train, hence bring the brakes of the train to a stop. So the functional role, the braking translates pneumatic energy into mechanical braking system. So this view of the pneumatic brake system, we have the front brake mechanism, we have the brake shoes of the standard here, and the brake disc. This is it. This is the full brake disc. This one is responsible for stopping the train after the mechanism of the pneumatic system, that is the whole thing. So we selected the materials, that is what? ASI, this one also, and stainless steel, that reason for hardness and the wear and resistance to repeated braking without deformation. So under the boogie, every material that is selected is of high strength and high yield strength and all that, because it receives, that is where the total load of the train is what? Resting. So air reservoirs, as I said, the purpose of the air reservoirs is to store compressed air used in the pneumatic braking system in secondary, and then secondary air suspension. Alright, so the battery that we talked about, so reason, that is that, this is the battery. Yes, we talked about all these things, the transformers, the real parts. Yeah. So I think with everything said, this is what basically we did in our or during our research. This is what we were able to come up with, as we saw in the video, the train as we design, as we can move backwards to see the full train. So this is what we did at the end of our project. This is what we had. This is the full the streamlined front face for air drag and aerodynamic system. So I would like to end my presentation here by thanking you all for allowing me to present what I have. Thank you.
I'll mention the name of the team members, then we'll give it to the judges. Francis Dadson, Richard Kusi, Stephen Nanadadzi, Erica Abnabuchi, Obed Jesse, Adam Ishmael, Sam Odier, and Desmond Aiti. So, judges, please. Let's start with
Yeah, you did. You did very well, but I didn't see anything about the boogies. Sorry, the coupling. Is this a multiple unit or it is a tree? It's a multiple unit. Okay, so it doesn't matter. All right. Now, you didn't talk about what controls the pantograph. It uses pneumatic hand. That is correct. It uses air. All right. Now, you didn't talk about the type of boogies that is it a bogo or boko? You are just boogies. But you are so types no, I'm calling the wheel set. Okay. The wheel set tells us COCO also means that we have click reset on the book, right? Now, in your design, you should be able to mention that, right? Good. Good. And you've done very well.
All right. Thank you. Team Cardis, well done for this work. I have a few questions. To be honest with you, let me touch on the presentations. Please forgive if I hit you hard, okay? It's for your own good. Now, when it comes to the slides, in fact, there are issues with the slides. Okay? This is PowerPoint. It's not going far. I hope you understand. So let me bring the salient points. It's too much. The writers are too much. The font size, you have issues with the font size. No slide number. Right? So please take note of that. Now, we're talking about, we spoke about the aerodynamic design, right? Now, what is the purpose of that aerodynamic design to the whole structure? That's my first question. Okay, I think that's okay. Now, when it comes to the component selection, I think I have an issue with the component selection. Because when we talk about design, component selection is a key, right? Because you are going to implement, right? Okay. We are talking about, we're using the steel, we are talking about, is it AISI, it's 130 or something. Now, when you are selecting component, you don't pick only one component. This is how you do it. At least pick about 2 or 3 components, that is multiple components. Then you assess them. How do you assess them? Based on their properties, right? So you compare, you analyze them before now, you can now what? You can now see really that, oh, this is the reason why we selected this component. Again, talking about the design, yeah, I think there are a few calculations that you did, but we didn't see any calculation in this design. Okay, talking about you measure some dimensions and that stuff. But we didn't see anything like that. And let us see, because you can't see that you design without bringing some equations out. How we display it is very, very important. Then I have last 2 questions. You guys talking about the motor. Under what condition do you select? We were talking about the induction or traction motor. I don't want to worry too much about the difference between the traction and induction of the motor. Under what condition do you select? We were mentioning about 25 kilovolts. And 25 kilovolts is not a small voltage. But then we're just we're talking about voltage, current, we're just confused. So, but from your right ups, you mentioned 25 kilovolts. Under what condition do you select the 25 kilovolts?
I would like to come in. And then that one from the main power rail, we see that the voltage is very high. That is 25 kilovolts, about 25 kilovolts of AC. And
so how did you get that is 25? That's what
based on the research, we want to know that mostly the main power rail actually use about 25 kilovolts of AC. Just about. So we can just overhead in the main rail. That's the grid system. Use about 25 kilovolts of AC. That's the main the source. Before we step it down to a dual voltage of about 1 to 3 kilovolts. So that through the transformer that we just added, and then through the traction converter, we just convert everything. The traction converter has rectifiers and then inverters, which convert it back to DC in order to have a range, because in order to control the speed of the train, you need to modify the thing in such a way that the range of frequency to control the speed of the motor has to be in a way that we can actually control the speed. So we have to convert it back to DC through the traction converter, which houses the inverter and then the rectifier.
Let me ask this question. Please, with the induction motor, is it AC or DC?
It's an AC 3-phase induction motor.
And then what is the purpose of the induction motor in this system?
In this system, the induction motor actually provides a torque, that is a turning force, to rotate the wheels. But it cannot access the power directly from the wheel. That's why we have to step it down, do some modulation in the range of the frequency in order to control the speed of the train.
Okay, I think I'll consider something. So, but our advisor, please take your time and go through that, because there are a lot of issues with that. The section of the motor, we're talking about the rating. Very, very important. Because you didn't mention about transformers and stuff like that. You have to understand how we display. So, I want to ask you a question. Now, my last question about the braking system. You're talking about you are using pneumatic, right? Why not hydraulics? So we have the hydraulic system and we have the pneumatic system, right? Why not hydraulic but pneumatic system? Thank you.
We decided to choose the pneumatic system, that braking system.
As I said, when it comes to design, you don't just decide. You have to do serious research. And it comes with equations. So, if you talk about you decided, now I differ from that place. So you have to research why pneumatic but not hydraulic braking system. How it is there. So, but you know, you've done a good job. Seriously, you've done a good job. The design, you've done a good job. Well done, okay?
All right. I'm highly impressed with the presentation. The confidence level of the presenter very solid, and the knowledge you demonstrated in terms of this, your competency is also very good. Of course, my colleague has said it all. Just forgive us. We sometimes want to be truthful with you, because this is a stepping stone for a greater height. All right. So, as I said, the issues of the power money as well, are not going to mention, so we should pay attention to that. The other thing that, of course, are of relevance that I want to make mention is that the type of train we're considering in terms of, is it a double-headed train or is it a one-headed train? It's a double-headed train. So, is it because I'm viewing it from this side, maybe you can help me? I'm not, because I can see the front case, but if it's double-headed, then what about the back side? We that have been projected, because I was expecting there supposed to be some protruding aspect, as we have from the front, to suggest a double-headed train. Because for me, I see it as a one-headed train. Please help them with the microphone. So let them help you with the microphone so that we can hear you very well.
So we did the double-headed train, so it's a unidirectional. It can go this side and then drive back and forth. Because of how we were presenting it, that is why it didn't come out like that.
Okay. No, it's a design. So I know that to it. But you know, the way you've done it, you could still have extended the backside of this. You see, with this, it still shows that it's a one frame. You get it. So, of course, this kind of for railway system. My second question is that you need to position the of this we have in terms of your design. Okay, so okay, that's great. So what is if you could use the microphone, I can hear you very well.
For a signal is about 30,000 kilometers.
It's about 30,000. Okay.
And the frequency is about 2825 kilometers.
2825.
And the height is about 30,000 kilometers.
That's the standard. But that same applies to yours, right?
That is an about 350.
I don't very well. I have a problem with my ears, so forgive me.
Yes, that's the standard.
So that's the standard in terms of.
Well,
No, I want to know if the standard relates to standard in terms of their leg, or that is the dimension to your three designs.
not entirely, but what we did was we modified existing tree. So our tree also include other things that might have either increased the length or reduced the length of our design.
Okay, maybe. Okay, let me. I want to take you to somewhere because your honorable is here to help you. You don't like the bookies. See, we have 4 bookies. We ask bookies. The number of bookies depending on the training length because of the weights involved. I saw that the bookies is a 4 kind of bookie type. Okay, the bookies can have 4 wheel sets, right? Two. So the 4 sets, right? So that is what I projected. But 4 is 1, 2, 3, 4, 5. 5 by 4 give you what? No, how many 4 wheel sets do you have? You have 1. There are 3. Okay, forgive me. My second here. There are 3, right? So my point here is that for every training length, how do you understand us? Because in your design of you have any lock at that section? Yes, okay. That's okay. I step down. Okay, that's fine. So I can see that. All right.
Thank you.
Okay. Thank you very much.
I think that's the information. So it's one is going to make sure that we present within 10 minutes. I'm very okay. Thank you.
Thank you. more. Stephen and Mark administration. He's already enjoying it. Yes. Are we enjoying it? All right. Are you enjoying it? All right. Mesa. Mesa. Cut. All right. Join the next team. The team has 10 minutes to present. This team is Team Africa. If I mention it very well. Team orders. And I'm seeing their team members. First, she told me that and please you call on
Camera 2.
So please, at this point, we call upon Principal and Mr. Eugene to introduce our targets for us. Principal, please.
Hello. Hello. Yeah, so thank you very much for the opportunity. So I'm the person of the year and our teaching assistant. Card. So the card is actually brought to you by a collaboration and then with I Design and Engineering Alliance, right? So they are a global community reshaping design and engineering across all bodies. So the founder is actually the person, Zishon Somoro. I think he's online. So let's appreciate him. Let's appreciate him.
the next person is actually the director. The director is in the person of Jose Celestine Donald. Jose Celestine Donald. And then the next person I'm going to introduce is also the community admin. Is Namana. Introducing the judges. We have Jonas Puchis. Yes, Jonas Puchis, the first judge. And the second.
Thank you very much. Now we join the Zoom, we see our video, and we giving us their feedback. Thank you.
We are going to pass the cash challenges under the administration of
So a little background on why the key concepts we decided to mention Ghana. We still have a okay, and then over the years, they are both sides. It has a higher of it's all time, mostly especially suited for the going center. So next suited for the going center, designing key structural components for a passenger train. We develop a concept that supports local manufacturing of trains. So we're using a few weeks ago. So we use train dimensional to ensure it can match our real further research. And give us more details on that.
As she said, we did all our knowledge. And then mechanical analysis to continue with our modeling. And yes, further we went to Blender to continue. We wanted to go to Fusion also, but we had a little technical issues. So as you can see here, this was where we started with the conceptualization of the idea with our design. You can see it is very types of mechanisms. So to design the boogie system over here, we will explain this much more later. This is some of the dimensions of the training. So this is our boogie unit, designed in SolidWorks. So we have another specialization, and she explained that
clear.
So we are moving from standard to so what will come it's open using we also have washrooms embedded. And once again, I want to explain that our train was also have washrooms embedded. And once again, I want to explain that our train was designed for long distances. So there is not a lot of people standing. We have, once again, our train built for comfort. So, as I said, the number of people is just about 90. So we also have chairs designed with charging ports. So yes. So this is a whole design about how the chair should look like. This you see over here is a dedicated area. It works as like a table. So you pull down and you work on a working station. So the next one will just give you the working four units. And this 4 units, as I said, each will take about 90. So yes. Now I explain the functionalities, as I said, to enhance ride and comfort and support. So if you look at our design, you can see that what you can't enter this train and be sweating. I even forgot to tell you there is an aircon inside. So we also have safety. There are safety measures embedded in the systems. There is also how we manufacture this train. It was done in such a way that what it can be easily taken apart. planning system working in the narrow and the standard gauge. So once again, this is Steve Adams, and our design was actually a real life design. We work with dimensions, actual dimensions from models that already exist. We embedded that into our designs, and we did this train, a modern train, to help our
Please, let's show some appreciation.
Well done for your presentation. With your slides, you have some small issues on the slide, but at least you are on point. Well done. And with your design, I really enjoyed it. And the way you designed the whole thing, I'm impressed. See, you guys are very smart, because looking at the topic is about design. So we realize that you didn't talk more about the component selection. That is the advantage. So you are safe. And with your design, so you've done very well.
Let's show some appreciation. Please, are we learning? We are giving some points that will help us, especially the presentation. Mesa. Okay. Let's not forget that this is under the Stephen Amowak-led administration. And it's a collaboration with ideas, the feeling of ideas, international designers and engineers alike. Are we ready for the next two? Are we ready? Are we ready? So I'm into the next team. When I say card, say let's build. Card. Let's build. Card. Let's build. Mesa. Innovate. We are waiting for the PPT. So the next thing is ready. Team, I'll mention the name of their team members. Peniel, Yulan, Akuma, Emmanuel, Kelvin, Echampo, Lily, Faye, Julian, Simido. Sorry. The next team is Card Olympians. Card Olympians. Okay, so the name of their members is Appleton, Worship, Epi Richard, Nav Solomon, Edu James, Kufiet, Wafu, Francis Akwawa, Francis Junior. So please welcome Khan Olympic.
Good morning, everyone. I'd like to thank everyone for your presence and also appreciate our esteemed panelists. The name of our team, my name is Apples in Worship, and the name of my team is Car. So our content includes what the diesel electric train is. So a diesel electric train is a diesel electric train. A diesel electric train is a type of thing that uses the engine to power traction motors. What is to convert electrical energy into mechanical energy that is used to move the train wheels and move the locomotive. So please play the video. This is a typical design of a diesel electric locomotive. This is the engine compartment and then the driver cabin, consisting of the wheel, air compressors, and then couplings. This is a typical design. So all these drawings were made by Autodesk AutoCAD. Yes. Please, the next slide. So we'll now look at the components of a diesel electric train. The first component we are going to look at is the locomotive. That was what I displayed previously. And the locomotive consists of the driver cabin, the engine compartment, heat exchangers, lateral hydraulic, yes, and then the wheels, some boxes, etc. Yeah, so this is the framework of our locomotive containing all our dimensions. So this framework, the material used was aluminium. Yes, aluminium was used. The material to be used for this type of framework is aluminium because it is lightweight. Yeah, and it can move at a very good speed depending on the amount of weight that is applied. So this is a typical dimension free of our electricity. This is also of the electric locomotive that is the radiator. It is responsible for exchanging heat between the environment. So as the locomotive, the air flows and cools the engine. The next system we are going to look at is the buoy system. And the buoy system consists of the damper spring, the damper spring, the wheel, the axle, and then the so this let's move to this. So this is a typical design. So this is the dimension drawing of our wheels with all dimensions given, and with normally the train wheels are angled as 90 to the wheels. So it didn't really display, but this is a typical drawing of our wheels. This is the next slide. And this is our damper. It is possible for vertical motion. It is possible for reducing vertical vibrations in the train and enhancing passenger comfortability. So when you are in the train, you don't experience any vertical motion, so that the train moves smoothly to prevent movement. This is the damper, and then this part is what is attached to the chassis system. So it's something like a flange that connects the bearing box. This yellow part is the bearing box. damper, which is then connected to the chassis frame. So these are dimensions part of our damper. Please, the next one. These are also dimensions part of the damper, with all dimensions being here. This is also a dimension part of the bearing box. Now we are moving on to the chassis system. The chassis system forms the framework on which all the weight of the train sits on. So this is normally, the material normally used for this framework is a high strength steel, which is able to withstand all the stresses of the train and hold the weight of the train. Also, the chassis has 3 openings here, which the wheels will be attached to. So this opening, this shows that the chassis will house a cocoa boogie. A cocoa boogie is a boogie, a three type boogie. So one boogie will be mounted here, another one here, and another one here. And this is a typical design of the chassis. The chassis shown previously was for the locomotive, and this is for the passenger compartment. This consists of the wheels, the coupler, and the other. So this is the dimensions we use for, and our dimensions were gotten from research online, and these are the dimension parts of the chassis frame. Also, with this drawing here, this drawing is shows a hydraulic, the cast of the train. So with this, it's normally a hydraulic or a spring. So it's normally connects the trains together. Now we are moving on to the coupler. The coupler is responsible for connecting trains of different cars together. This is a buffer coupler. It is manual after they've been joined. And so this is the dimension part of the coupler. The next slide, please. Yes, this is the hook. Yes, these are all parts of the coupler. Passenger compartment is the compartment that houses the human beings that are going to board the train, consisting of the frame and then windows, doors, and then the boogie system. So this is a framework of the system. So this is a framework of the
they have done, they took their time. Look at the way they assembled everything, explaining everything. It is clear. Even if you don't have any idea. The only thing that I did not, in fact, I did not enjoy is, if you look at, let's see the first slide. That is, there were some few issues, but I don't think it should be a problem. It's like handouts, right? So we have a presentation, like we're here too, right? So
My